All right, so I'm reading this problem about a Mini Cooper crashing onto a heavy-duty Dodge Ram, and just thought I'd check out a real crash test, see what it looks like. Whoa, that's scary. That's a good angle. Huh. Here's another view. Okay. Here's another view of it. High-speed camera. All right. So let's go to your worksheet. This problem with the Mini Cooper with a mass of 1132 kilograms is moving get rid of this. It's moving 38.5 meters per second, which is probably about 60, 70 miles per hour. And it crashes head on with a 5443 kilogram heavy duty Dodge Ram. Wish I had that truck. Cummins diesel. Anyway, the Dodge Ram's moving at 24.75 meter per second in the opposite direction. And it says the two vehicles become intertwined and mangled. So they stick together. With what velocity does the wreckage move? Okay, let's do that first. And then part B is, in a similar collision, the truck sends the Mini flying. Well, that's like the video you saw. So the video you saw was like part B. Part A, the two vehicles become intertwined and they stick together. Part B, we're going to assume they bounce off of each other. Okay? So let's begin. So this small box, try that again. This small box is to represent the Mini, and this box is supposed to be the Ram. Okay? I'm guessing they're moving towards each other before the collision. Okay? And then after the collision, so I'll write before collision, and I will copy these over. Move them over. Okay? Except after the collision, they stick. And I'm just going to take a wild guess here. I could be wrong. But I'm thinking that the Dodge Ram is going to win and everything's going to move to the left together. This chunk of metal that's all stuck together. So this is after the collision. all right? And so P total, momentum total, before is going to have to equal the total momentum after. That's the basic concept behind most momentum problems, if not all of them. Let's see here. Let's see what we know. All right, so there's two momentums before the collision. This is the mini, I'm going to call it M, and this is the ram, okay? And the mini and ram are one after the collision. So it's going to be momentum of mini. These vectors are going to add together. Momentum of ram. And the total momentum of the whole thing in the end acts as one unit. So I'm just going to write M plus R together. Okay. So from our diagram, we've got momentum to the right. This is the mini. And we've got momentum of the ram. Now, this vector has to go longer. So this is P for the mini, momentum of the mini. This is momentum of the ram. And those two vectors are placed head to tail. If I draw a vector from the tail of where I started to where I end, that's how I add vectors. This should be the momentum of the mini and ram when they're stuck together. Okay? So let's see what we know from the problem. So I can start figuring these vectors out. Let me move this down, please. There we go. Give myself a little more room. And let's just put our numbers in. I have the masses of both cars. The Cooper is moving 38.5 meters per second. So in the beginning, before the collision, the Mini, we're talking about 1132, that's the mass, times 38.5, that's the meters per second, that's the velocity, and that will give us the momentum initially of the Mini. The Ram is moving to the left at 24.75 meters a second. I'm going to leave out units to simplify our life. Okay. And the mass is 5443. 5443. Okay. And together, the total mass is going to be 1132. Let's just figure out what that is. 1132 and 5443. All right. This is 5, 7, 5, 6. So the mass at the end of everything stuck together is 65, 75, and this velocity that I'm finding, I'm just going to call it V final. It's the final velocity of everything at the end that's all stuck together. Okay? And let's figure 1132 and 38.5. Let's see what those are. This over here. 1132, right, times 38.5. Wow, that's 43,582. Okay, and 5443 times 24.75 gives me 13,414. Okay. Wow, that's a big number. So let me just double check those. 1132 times 38.5 gives me 43,000 roughly. I'm getting a different number. Let me do it again. 1132 times 38.5 equals 43,582. Yeah, that's what I got the first time. Okay. 5443 times 24.75 gives me 134,714. I'll forget the quarter of a kilogram meter per second. Okay. So this means that these multiply together to give me 43,582. And these multiply together to give us 134,714. Okay? And I still don't know the final. So I should be able to solve this. I'm noticing that this vector, the magnitude, the 43,582, and this vector here, well, I'm not going to be able to add that. Let me take that out. Let me go at it a different way. This vector here, the magnitude only minus this vector here, right, is going to give me the red vector. So I'll do 134,714 minus 43,582. And that has to equal my 6575 times V final. And so let's rearrange this and make it look better. V final is going to be 134,714 minus 43,582 divided by 6575. V final equals, and let's see what that is. Okay. So we're talking about 134,714, which I already have in the calculator, minus 43,582 gives me that, 91,000, that sounds right. Divide by 6575, and that's 13.9, okay? So that seems reasonable. So what does this mean? It was 13.9 meters per second. Now I can check my units out. The kilograms will cancel out, and I should be left with just meters per second minus meters per second. So my units look cool. This is the final speed. So this is the speed of the intertwined wreckage. Okay? Now, that's part A.